Hello everyone and welcome to chapter 5, and in this chapter we are going to talk about the arrays, and let's see what we've got inside this chapter. At the beginning we only have an introduction, then array declaration and how the memory is interfaced with the arrays, and or how the arrays are stored inside the memory, and some terminologies, and then access an array element, how to initialize an array, how to process the contents of an array, how to assign an array to a value, how to pass an array to a function, and what are the two-dimensional arrays, and what is an array of string. So what is an array is called when it holds a string value, and these are the outlines which we are going to talk about in this lecture. So an array is a collection of data which they are in the same type. For example, we've got some different integer data and we've got some different character data. So an array can hold or we can say an array is a variable which can hold some different data or a collection of data of the same type. For example, a list of names, the names are in the same type, which are strings. A list of temperature, they are in double. A list of number, they are in integer. So an array is a variable which can hold a collection of data which are in the same type. So why do we need arrays? For example, you may have 5 test scores, or 100 test scores, or 1000 test scores, or 1 million test scores. Is it practical to define 1 million variables, 1 million different variables, which 1 million different names? No, it's not practical. So what are we going to do here? We need to declare an array which its type is, for example, integer or double or whatever, and we put all those values inside that array. So how to declare an array? So here we first need to specify the type of the array, the type of those data which can be held inside the array. So this is the type of the array, and this is the name of the array. For example, tests, for example, names, or x or y or whatever. This is going to be the name of the array. So far it's some like same like the declaring variables, but when we are using array, when we are declaring an array, we need to have those two brackets, opening bracket and the closing bracket, and we need to specify something sometimes here if we want to initialize the size of this array. So that means this is an array of integer which its name is tests, and it can hold 5 different data, and the data must be integers. So those values inside those bracket is going to be called a subscript or an index, which we are going to talk about them in detail. So this is how the array is going to be stored inside the memory. So the size of this array is 5. That means this array can hold 5 elements. So this is going to be the first element, second one, third one, fourth one, and fifth one. So this is how the memory is allocating the data belongs to an array. So those are 3 main important things of an array. So the int specifies the type, which is integer, and the test the name of the array, and 5 is the size of the array. So that means the number of the elements inside that array is going to be 5. We are going to be having 5 different elements. So, and this size also specifies the number of elements multiplied the size of each element. So here we can say the number of bytes for each element. So if we got 5 elements, so 5 multiplied by 5 bytes are going to be allocated inside the memory. So for example, here we've got int tests 5, and it allocates 20 bytes. Why? We've got 5 elements, and we are assuming that 4 bytes is going to be dedicated for each integer data. So 4 multiplied by 5 is going to be 20 bytes. So 20 bytes inside your memory is going to be allocated for that tests array. And this one, long double measures, and the size is 10. So this is going to be 80 bytes. Why? Because we are assuming that each long double data is going to allocate 8 bytes inside the memory, and 8 multiplied by 10 different long double elements is going to be 80 bytes. So how to define the size? And mostly the size of the array is going to be specified by the constants. For example, constant in size 5 and in test size, so the size is going to be 5. Why? Because this makes the program maintenance easier when the size of the array is going to be changed. So we just change this value, the size of the array is going to be changed. So this one is very important, accessing array elements. Now, for example, how many elements do we have in this array? 1, 2, 3, 4, 5. So the size of this array is 5. We've got 5 different elements, but subscript starts at 0. The first element is called the subscript 0, or the 0 index, or the element in index 0. Index 1, index 2, index 3, index 4. So we've got 5 elements, 5 different data, or 5 different elements, but the index of them, or the recognition of them, is called an index or subscript. So from now on I'm going to use index. So this element here is going to be accessed by the index 0. Why? Because it is located in the index 0, and this one in index 3, while it's the fourth element. Look, first element, second one, third one, fourth one, and fifth one, but the index or subscripts of them are starting from 0. And if we say it starts from the 0, so what's going to be the index of the last one? It's going to be the size minus 1. Always it's going to be the size minus 1. If the size is n, so the last element is going to be n minus 1. If it's 5, the last one is going to be in index 4. 5 minus 1 is 4. And let's say we have assumed that we have already defined declared this array, and the size of it is 5, and we are going to be assigning a value to each index. So we can't say test equals to 79. No, we can't, because this test is composed of 5 different elements or 5 different index. We can access each element by putting the index of it in between this bracket. So this one is going to be the first element, and we are assigning to 79, and then we are printing out this one. The 79 is going to be printed. C in tests the first element, the one in the index 1. So, and we are saying tests for the last one, the last element of the array is going to be this one, add to this one. So whatever is we are going to write down here or enter here, for example 79, and we are assuming that we are writing down 21, and the data inside this index or the last index is going to be 100. Why? Because 79 plus 21 is going to be 100. So, and we can't easily print down the tests or the array. We need to specify the index. We can't say cout test. Why? Because this test is holding 5 different variables or 5 different data. We need to specify which element to be printed, like we have done here. We need to specify that which element to be printed. And how to access the elements of an array. Look at here, we've got the num employee, this variable which type is integer, is going to be 6, and then we are declaring an array which is called hours, and the size of it is going to be this variable which is 6. So that means this array, its name is hours and its type is integer and the size of it is 6. That means the index of the array is starting from 0 up to 5. Okay, the first element is going to be located here, and the last element is going to be located here. And how to enter the data, or how to access each element. Okay, in order to enter the first element, we need to write down C in hours, first element, second one, third one, fourth one, fifth one, and sixth one. Okay, we know that the indexes are starting from 0 up to the size minus 1. Again, in order to access the array elements, in order to display the value inside the array, we can't easily write down C out hours. We need to specify the index. Okay, this is going to be printing the first element, and this one is going to be printing the last element. And this is how it is going to be stored inside the memory. The hours of index 0 is going to be 20, which, for example, we have entered it by through the console. And hours of index 1 is going to be 12, and the last one is going to be 15 in the when we entered. And when we show it, this is going to be shown, and this is how the array is going to be seen inside in terms of the memory. We can access any element of the array through a constant or through a literal the variable, like here cout test of 3. So the fourth element is going to be printed, or the element in the index number 3 is going to be printed. Here we can say int I equals to 5 cout test of I. So the element in index number 5 is going to be printed. So a question arises here. Let's see, we have got an array which its size is 1000. We may have 1,000,000, 100, or whatever. Is it practical to write down C in array of index 0, 1, 2, 3 up to 1000, to repeat that 1000 times? Is that practical? It's going to be 1000 lines of code, or 1000 statements, so it's not practical. So what are we going to do is using a loop to go through the array in order to enter the elements of that array, or to show the elements of that array. And in this example, we are assigning 99 to each element. So constant int array size is 5, int numbers equal, and the size is going to be array size, which is going to be 5. So that means we've got 5 elements. So we are mostly using the loop in order, or mostly using the for loop in order to access the elements of an array. So you can say int count equals to 0, count is less than array size, and count plus plus. So in each case, the count is 0 and 0 is less than 5, right? Numbers of count equals to 99. That means that the 0 index, or the first index, the index 0 of that array is going to be assigned to 99. Then the count is going to be 1. 1 is less than 5. Yes, the index number 1 of that array is going to be 99. So instead of saying, if you want to enter different value, we can say C in numbers of count. So at that time, we are going to enter different values to each element of that array. So we mostly use this kind of for loop in order to access the elements of an array. So if we look closer on the loop, what can we see? We start from the 0, that means the first index of the array, and we say less than array size. So we know that the last element of the array is array size minus 1. So this one is going to be true up to this one. And then the manuscript, or the what is called the index of the array, is starting from 0 and incrementing by 1 up to where? Up to the size minus 1. And when the index is less than the array size, and this is going to be the most perfect solution in order to access any element of the arrays. And we have got two different types of the array, and they are called global and local arrays. But the main difference between them is the global arrays, all elements of them is initialized by 0, initialized to 0 by default, but the local array, the elements of it are not going to be initialized first. So there is something in C++ which is called no bounds checking. What does that mean? That means when we are using an index of an array which is not valid, which is which is not in the size of the array. For example, we've got an array which its size is 3, and the elements are going to be 0, 1, and 2. We may assign a value to index number 7, so the C++ does accept that. It doesn't check for the bounds. Okay, so you can use subscripts or index that are beyond the bounds of the array. Look at here, we can learn it easier using this example. So the size of this array is 3, and the int values size, so we've got 3 indexes, 0, 1, and 2. And we are saying for count equals to 0, count is less than 5, count plus values of count equals to 100. That means values of 0, of 1, of 2, of 3, of 4 is going to be 100. The C++ does accept that. So it adds 2 more elements to be appended after the last element, which is going to be the index 2. So index 3 and index 4 is going to be added to that array. So this is how it's going to be stored in the memory. Look, we may have this array is going to be stored here. We are declaring this array, and the memory is going to be allocating these 3 elements. This is going to be before the array, and this is going to be after the array. So the first element is going to be stored here, second one here, third one here, and we have got only the size of the array. But when we add more elements, value of 3, it's going to be appended to the to the elements or to the memory locations after that memory location. Okay, so it's going to be value of 3 or value of 4. It doesn't add to those memory locations which are prior to the beginning of the array. Okay, so we had only those 3 valid indexes, but if we add more elements to that array which beyond the array size, it adds to them. It does accept them. How to initialize an array? For example, the size is 5, and the size of this array is going to be 5. So we're using this bracket and this one to start on the end of the array. We can specify 7 different elements, this one and so on. This one is going to be located in the index number 0, 1, 2, 3, 4. Okay, so that means we have from 0 up to 4. So you can't initialize more elements than the size of the array here when in the time of the initialization. We can't do that. And look at here, we've got 12. The size is going to be 12. First one, second one, third one, fourth, fifth, and so on up to the 12th one. But this is going to be the index number 0, and this one is going to be the index number 11. So we start from 0 up to less than 12 and plus, and we are going to add what we are going to print the months. But if we say count, so it's prints month number 0, which we don't have. So we add the count to 1 in the printing console. So it prints 1, 2, 3 up to 12. Okay, so then these values are going to be the number of the days in each month. So the number of the days in month 1 is going to be 31, 28 for the second month, and third month is going to be this one, and the program will show you this as the output. So in test 3 we are initializing 3 different data to that it's valid, but this one isn't invalid. Why? Because this is, you consider it as a plain variable, not an array, a normal variable, not an array. So we need to write down those two brackets, then we can initialize any value to it. And this is how we can store an array to what is called a memory when we have, less elements than the size of the array. So the size of this array is 7, but we have initialized only 4 elements. So what's going to happen for the remaining 3 elements? They are going to be filled with 0. 0 is going to be placed them, which is going to be the initial value of the memory locations in your random access memory. So the first one is going to be stored in index 0, and this one is going to be stored in index number 3. 4, index 5 and index 6 are going to be filled with zeros. Implicit array size, in those kinds or those type of arrays which we are not specifying the size. So how the size is going to be calculated? By the number of the elements in the initialization step. So the size of this array is going to be 4. That means the memory is going to allocate 4 memory locations to the array. Okay, how to initialize an array with a string? So you can say size is equal to 6, and the name of the array and the type is going to be char, and this is going to be the data to be held inside that array. So this is going to be the index number 0, 1, 2, 3, 4, and we know that we've got index number 5. Why? Because the size is 6, but we can't put any value because we need to leave a null value at the end of each string. So this is \0 is going to be a null determination of each string. We need to have at the end of each string, and it must add it explicitly. So the values are going to be stored, or we can store the values like this one, character by character. This is going to be the index number 0, index number 4, and this is going to be the index number 5, which is the null termination. So how to process the content of an array, or how to process the elements of an array? So the array elements can be treated as an ordinary variable, such as, for example, test of I, of test or test of 0 can be processed as X or Y or Z or whatever, any regular or ordinary variable. So we can process them using those operators. Look at here, and this sometimes leads to some confusion. When you say tests of I plus plus, that means this element, tests of, let's say I equals to 1, okay? Tests of 1, the element in index number 1 is going to be incremented by 1, but this one is I equals to 1. Tests of I plus plus, that means this statement returns what? Returns tests of 2, because I was 1 and this is going to be incremented by 1, it's going to be 2, so it returns tests of index 2. This sometimes leads to confusion. You need to be careful about that. And here, how to assign a value into an array, or sorry, how to copy one array to another. We can't directly say new test equal to test if they are array. It doesn't work, but we need to assign them element by element. For I equals to 0, I is less than array size I plus plus. New tests of index 0 equals to tests index of 0. It's going to be 1. I is going to be 1. New tests of index 1 is going to be the test of index 1. So this is how you can assign an array to another array. How to show or display or print the content of an array. So we can pass the name of the array if we have a string or character array. You can pass only the name of the array, but this only works with character arrays. So when an array contains a string or some characters, this only works in this case. But if you got integer array or double or whatever, apart from characters, this method doesn't work. You need to specify the element. We need to specify which element to be printed. So in order to print the print all the elements of that array tests, we need to create a for loop to print element by element from 0 up to the size minus 1. So summing and averaging array elements, these are some calculations you can do on, or you can perform on your array. So you are defining, for example, I or t name or whatever, double average and sum equals to 0. At the beginning we don't have anything stored in the sum and the average, so we are going to start looking or accessing each element of the array and starting from 0. And when we are accessing the element in the index 0, we say the old sum equals to the new sum plus tests of index number 0. Okay, so the tnum is going to be 1. 1 is less than size, yes, is going to be added to the old sum. They are going to be added all together. Once we submit all the elements inside that array, we say average equals to sum divided by size. Okay, so the size of the array is going to be 5, and that means we've got 5 elements. We add them together and divide them by size, so the average is going to be calculated. Finding the highest value in an array, there is a little trick here. For example, int count, int highest. So at the beginning we are saying the highest value is the element in the index number 0. The first element of the array is going to be assigned to the highest. That means the highest element is the first element, and then we are checking with the other elements. And now we have already accessed the first element, and we don't need to access the first element again, so we're starting from 1, the second element. So the count is less than size, yes, let's assume if that number we are accessing, which is index number 1, is greater than the old highest, which was index number 0. What's going to happen if it is true? The highest is becoming this number which we just accessed. If not, the highest remains at the first element. So it goes to check the third value again. Okay, so the count is becoming 2. If that number which we are with that element which we have accessed now is greater than highest, highest is becoming that number, else the highest remains as the previous value. So when the highest is calculated, when the loop is terminated, we are going to be having the highest value here, and this applies for the lowest again. So the lowest is going to be the first element, and starting from 1, if that number we are accessing is less than the lowest, if it's less than the previous one, what happens? The lowest is going to be this number, else nothing happens, it goes to the element after. So when the loop is terminated, we are going to have the lowest value here. For the partially filled arrays, which we haven't specified the size, so and we don't know how much the data are going to be stored in that array, or is going to be held in that array. So you need to make the array large enough to hold the largest expected number of elements, and you may expect 10 and you don't know the exact number. So let's say you specify the size to 15, for example, and also every time you need to use a counter variable such as counter or I or whatever to keep track of the number of items stored in each array, or to access each element of that. Comparing arrays. So in order to compare two arrays, you must compare elements by element. You can't say if first array equals to the second array. No, that doesn't work. So we need to compare elements by element. Let's see. Size is 5, first array of size, second array of size, and the elements are going to be this, which is, they are obviously equals, and bool arrays equal is true. At the beginning we say that they are true or they are false or whatever, because we are going to change that value according to the logic of the program. The count is 0 in order to access the elements of the array, while arrays equal, that means this one is true, and count is less than size, which we know we have used for loop, and we can use for loop as well here. If first array of count, that means first array of index 0 is not equal to the second array of index 0, if this one is not equal to this one, what happens? Arrays equal is going to be false, but they are equal, so this one is not going to be executed. Count plus plus count is becoming 1. Yes, 1 is less than 5, so it checks that one with that one, so it's not true, they are equal, so this one is not going to be executed. And we are going to check the third value, fourth value, and the fifth value, so nothing changed. The array is equal remains true, it's not going to be false. Why? Because this condition doesn't get its true condition, okay, its true phase, so it remains false, it remains false, so this one is not going to be executed. So the arrays equal, this bool variable is remaining true. If this one is true, yes, it's true, the arrays are equal. Let's see, this one is 21 and this one is 20. When it accesses this element, first array of count, which is 3, is not equal to second arrays of count. Yes, they are not equal, so this condition is true. The array is equal is becoming false. What happens? It comes back here, the array is equal is false, so the loop is going to be stopped and it directly comes here. The array is equal is false, it became false, so this one is not going to be executed, this one is going to be executed.